from?
South Carolina.
And what do you do?
I am a Teller developer evangelist.
And you're an MVP in what?
C#.
You know a lot about C#, don't you?
I like to think so.
Yeah. Let's talk about C#. What should we talk about?
I'm really into Fluent interfaces, so how about we go there?
All right, I'm good with that.
Okay.
Let's start by define a fluent interface. What does that word mean, fluent interface?
A Fluent interface is an internal domain-specific language, typically implemented with method chaining.
Okay, let's back up one more time. First, you said a couple things there. What is a domain-specific language?
A DSL, so a domain-specific language, you have your very general languages like C#, which can do just about everything. And then domain-specific languages are narrow. They're more narrow, they're describing something more specific.
Okay.
Actually, if that's correct.
All right. So a fluent interface is a type of domain-specific language.
Right, it's a type of domain-specific
And it uses
language.
something called method chaining, which is what?
Method chaining is where when you call a method, you're returning a type that can then have another method called upon it.
Okay.
So the thing about this is you primarily need to have some type of context, which is going to be the exact same object that you're working on. If you are working on foo and you call bar, it's going to return foo.
Okay.
So then you can continue and call dot bar2.
Okay. So foo dot bar, using an instance of an object,
Right.
a method on that object to return a new instance of the same type.
If you're working with immutable types, yes, some don't work with immutable types. Sometimes you're actually changing the object as you go along. A typical method used in Fluent interfaces is with. And if I don't have something that's immutable, if I have a context class that's describing something that is containing policies or is containing some other type of object, then I can say with.
What was it, policies?
Policies.
Policies, okay.
Southern accent.
Yeah.
Policies. So if you call dot with, usually you may be modifying the context itself and then returning the exact same object back out.
Okay.
So this keeps you from saying context dot with this semicolon, context dot with this semicolon, or you might see this a lot with list dot add a string. Some string list. I have strings dot add passing in a string semicolon, strings dot add passing in another string semicolon.
Okay. So rather than that, you're going to just chain all these things together, get rid of the semicolons and
Exactly.
chain them all together.
Right, you're going to get rid of the semicolons, chain them together, and that's a very simplistic example, but it tends to lead to something that's more readable. It's more declarative.
That's the goal, right? We want
Right.
something that's more readable, so when I come back and look at this code later, or when somebody else comes and look to it, they can more quickly understand what the code's trying to do.
Exactly. As English speakers, we read from left to right. However, we code from the outside in. We call some method. Well, I need this value, so I'm going to call another method within that method. You may break it apart and put it on different lines, but in many instances, it's from the outside in.
Okay. All right. Can you give me an example?
A good example of Fluent interface is link.
Okay.
You link to objects. You're working on some type of IEnumerable T. So it's IEnumerable strings, IEnumerable ints, IEnumerable policies, as I was speaking of before.
Mm-hmm.
And I can call .where on that and filter them out. So the typical imperative code, which is, I'm describing how I'm doing things rather than what I'm doing. In imperative code, I would, create a list, or I'd actually take in a list into my method. I would create a new list, loop through the original list, and add things to it based upon some type of criteria.
Okay.
I'd have, a loop and an embedded if statement. Now,
And I've written code like that in the past.
right, what I'm saying is that's imperative code. It's not as readable as declarative code, where I would say my list.where and pass in some type of function to describe, or lambda expression to describe how I want to filter the list. Now, whenever I see this piece of code that has just got where in it, I know exactly what it's doing. I can mentally block out that piece unless something is wrong with the return type.
Okay. So what you end up with is, rather than having a loop, a list and a loop and adding to some other brand new list and then returning that brand new list, now you've got just one line of code.
Exactly.
Um,
That
sort of
states
like-
what it's doing.
It states what it's doing, it states more clearly. The one thing I think a lot of people have issues with is the code you described, we're passing in a function as a parameter. So people, it's hard for them to get their head around that.
Right. With some of the newer innovations in C#, some people shy away from it. But saying that you can't use it because no one understands it is like saying that in 1999, or back when we started C#, no one understands object-oriented programming languages, so we should stick to procedural programming languages.
That's a great point. So, this is our discussion I've had before, where we say our code is too smart for our developers. We should dumb down our code, or do we, smart up our developers and get them to understand the pieces that are new to them, and then it just all makes sense. I think Link is a good part of that. We're still relatively new. A lot of people haven't learned it yet, but once they do learn it, then it does make code a lot more readable.
Certainly, and any type of Fluent interfaces you may have seen out there, you can pretty much follow it. I've got this. I'm going to this context is with these types of objects, and it's going to call this method, or it's going to call some type of functionality, and then it's going to do this. I can look at that piece of code and be like, that's pretty. I see what's happening there. I may need to go into it and see what's happening in the method if there's some issue, but if you look at the imperative version of that, it is much more complicated. It requires a lot more thinking. Whenever you see any type of loop, any type of if statement, your brain immediately has to decipher that. If I see a declarative statement, then I know what it's doing based upon what it says. Now, it goes into an interesting point that you should name your methods what they're doing, not how they're doing it, and it pretty much leads to very clean interfaces. A very clean Fluent interface if you're designing in that manner. But even nowadays, people still tend to write link statements with these very complex lambda expressions. You may have seen this. Anytime you see a lambda expression with curly braces, so the lambda is very thick.
Okay.
I think there's been a little bit of neglect in refactoring those. They can be stated more declaratively.
You're talking about now when you're dealing with like lambdas that can be converted into link to objects. Is that what you mean?
No, I'm saying the lambda is being used in something like link to objects or
Okay.
in another context. And whenever...
So I'm not sure if this is what you're talking about, but I use lambdas for if I'm doing a simple filtering, a simpler ordering of lists. I might use a lambda, some list.where, and put a lambda in there. But if I'm doing a lot of different things, like I have some relatively complicated filtering criteria and some ordering criteria, I may use the more SQL-like syntax,
Right.
from T and whatever, select where this, order by that, select this.
Okay, yeah, those type of syntaxes, they don't really get very deep into it or into the complexity of that lambdas can contain.
You're talking about something different, I think.
Yeah, I believe so. I was going down the route that sometimes people are passing in lambdas that get you in that mental loop again. You have to think about what's happening inside this lambda expression.
Oh, I see what you're saying. Okay. So,
And
if the lambda isn't simplifying things, if the lambda is in itself complicated, then you need to refactor again.
exactly. You
And
need
how
to.
so?
Well, if you're in link to objects, you can take that lambda expression and put it into a delegate. Now that will, you can call it directly. You can put it directly into your link statement. However, you should be very careful with that when you're using something like iCreable. Whenever you pass in a delegate, which a name method is going to be used as a delegate, what will happen is the IEnumerable version is called, and when that happens, you can have like I keep talking about policies. Say you have some type of policies and you're pulling them out of the database, and you've used the where clause to filter them, and you only want something with a specific number or after a certain date. So maybe if it's after a certain date, you're expecting like 10 to come back. Well, if you refactor your lambda and you don't do it correctly, you're not paying attention to what form you're using, the IEnumerable version will be called, and then it's going to pull everything out of the database or from the service or wherever that queryable is calling to, and then it's going to filter it in memory. So it's very important to understand that when you're using lambda expressions, you may be using delegates, you may be using expression trees. It really depends on whether you're in something like linked to objects or if you're in something like linked to Entity Framework.
Okay, this becomes a big issue when you're actually hitting the database and whether or not you're pulling up a lot of data and filtering on the client side versus, or whether you're not sending a lot of queries down to the database server.
People should just be aware of that. I want to go with this. Now, one thing I find really interesting is when people are talking about like functional programming in C#, they tend to focus on the fact that you have functions now, funcs, and actions. And those are really just transformations of delegates. They are functions and actions, and or actually is a form of a function. And they can be used that way. But what really made C# more functional were extension methods. The fact that I can take a class and just that I do not have access to and add things to it. Now those are kind of like global functions in a way in another language that take in that class as the first parameter.
Right.
But since we're an object-oriented programming language, that gives us the feeling like we're working with objects. It feels object-oriented.
Sure.
Right.
Extension methods also, to me, they seem more readable because rather than passing an object, and this is the whole inside-out thing again, rather than passing an object in as an argument to an extension method, we're just making that method look as if it's a method on the original object.
Right. So, yes, that actually brings you to where does the functionality belong to. And if you have random methods in some type of utility class,
right,
they don't actually belong to that utility class. And that's a form of cohesion called coincidental cohesion. You've probably heard of stripe for high cohesion.
Just recently, as a matter of fact.
Well, the stripe for high cohesion is probably better related if I explain it in terms of the single responsibility principle. That is that this method should do one thing and one thing only. This class should have one responsibility and one responsibility only.
That's high cohesion?
That will lead to high cohesion.
Okay.
It really depends on how much responsibility these things are taking on. And utility classes take on way too much responsibility.
Okay, all right.
They have all kinds of methods in
Sure.
there. So utility classes, lowest form of cohesion. But then you get to your helper classes that, like I have, say I have a stream helper that has methods that only pertain to stream. Well, that has something called logical cohesion, which is kind of like the utility class, but they all pertain to the same subject.
Okay.
Now, there's a few other forms of cohesion that I won't go into, like temporal cohesion, but the highest form of cohesion is functional cohesion. This belongs here.
Okay.
And extension methods give us that ability. We don't have access to that class, but I can assign this method to that class, like it really does belong to it.
Okay, so we're able to extend the class, and that adds to the cohesion of it because of all our methods, as far as the client is concerned, as far as the people that are actually calling those methods, it looks like it belongs to the class that it's acting on,
Right.
class that it's extending.
In your code, it looks like that.
Right.
And that's very important because it does make your code more readable. You're no longer calling like tons of little stack methods and stack classes to do something. You're using the object. That actually leads to a Fluent interface in and of itself, because I no longer have to call a string helper,
Right.
pass in the string and then do something to it, and then call string helper on the outside. It's the outside in thing all over again.
Exactly, you can just call string dot whatever your helper method was. It
Yeah.
looks like you've just added these methods to it.
Yeah, I can call like string dot reverse, string dot this, string dot that, and the interesting thing there is that string is immutable, so you're always getting a new string back. Immutable being that I can't change the value. I get another, whenever I call something that would change the value, I actually get another string.
Right.
Whereas mutability, I have or immutable classes, I may be changing the inside of it. Now,
String is also sealed, and using extension methods, we can change a sealed class, which is almost impossible to do without that.
exactly.
We certainly don't have the source code of a string class, and we can't subclass it.
But you're technically not changing it. That's great because we adhere to the open-close principle,
Which is
that classes should be open for extension but closed to modification.
this is one way of extending a class without even having the ability to modify it.
Right, those extension methods can't touch anything internal to the class. In fact, it's just a static method that takes in the class or the object as its first parameter, marked with this. The interesting thing is when you're designing a Fluent interface, if you give methods certain names and do certain things with them, then you can actually hijack query expressions. So query expressions is that form of link that looks like SQL.
Okay.
So typically when you see one of these query expressions, you're thinking, oh, this operates on some IEnumerable T.
Typically it does.
Yes, typically it does.
Or iQueryable.
Yeah, but it's iQueryable implements IEnumerable.
Okay.
So in this case, but the thing is that's completely wrong. People have that impression, but the only thing that's actually required is that it implements a method of a certain name that matches the right interface or the right method signature. And what that allows you to do is give it your own select, your own projection, give it your own where, give it your own order by.
Okay.
And you can put those directly on your class.
So if I create a class that has a select method and a where method and order by method, then I basically created a class that can look like link. I
Yes.
can call it like link.
You can call it just like link. So what I did to prove this works, I actually took functions. And I stated, it'd be really cool if I could declaratively state how I'm composing this function from other functions. So I had a square function, I had a square root function, and I wanted to be able to make a hypotenuse function from that. So what I ended up designing was this little method that allowed me to say from h in square, for height, from w in square, select square root h plus w. And it gave me a hypotenuse function that takes in, h and w, the two values.
And you're able to call it with this SQL like link syntax.
Exactly.
Very cool.
Yeah, so it's just interesting what you can do with the language if you just take the time to look at.
Okay, and you're blogging about this a lot.
Oh yes, my blog is codefoodguru.com.
Code with a K.
K, yes, like Kung Fu, KODEFUGURU.com.
.com.
All right. Great.
Excellent. Thanks very much,
Thank
Chris.
you.
Appreciate your time.
No problem.